We're now moving on to example 3, question number 2 in the limits chapter. And for question number 2, we're given another piecewise function, and we need to follow that up by graphing those and answering the following limit questions. So for this piecewise function, we're given a few functions from pre-calculus 11. So we're given here a linear function to start. And if I rewrite the linear function here on the side, you should remember that the y-intercept is positive 1 and the slope is negative 1. And this is valid when x is less than 2. So if I put my y-intercept right here, and if I have a negative slope, then I can continue the graph by putting in a few dots there. And when I get to x equals to 2, I need to have a hole right there. And the reason why I have a hole when x equals to 2 is because we're not actually equal at that point. So that green line right there is y equals to negative x plus 1, and that's valid when x is less than 2. Okay, let's erase that, and now let's move on to the middle graph. And the middle graph is just a parabola. So this is, let me just rewrite the parabola right over here. And from pre-calculus 11, you should remember that the vertex is 2, negative 1, and this parabola opens up. All right, so here's the vertex right here. And if you remember with parabolas, from the vertex you go over 1, up 1, and then you go over 2 spots and you go up 4. So 1, 2, 3, 4. So there's another point right there. And let me just erase that. And let's go ahead and connect the dots here and complete the parabola here. So there's my parabola. So that's y equals to x minus 2 all squared minus 1. So I'm going to erase all that. And then finally, we need to graph 0 when x equals to 2. So when x equals to 2, there is a y height of 0. So there's just a dot right here. So that's this dot right here when x equals to 2. All right, now let's go ahead and answer the limit questions. So the very first question is, what is the limit when x approaches 2 from the left-hand side? So if I'm approaching 2 from the left-hand side, so here's the left-hand side, I'm going down, and as I approach x equals to 2, the height that I get to is actually going to be negative 1. And if I approach 2 from the right-hand side, which is letter B, so for letter B, I'm approaching 2 from the right-hand side, so I need to follow this graph here and go down. So I'm approaching x equals to 2 from the right-hand side, and the height that I get to there is also negative 1. And since the left-hand limit and the right-hand limit are equal, since these two guys are equal, this overall limit has to be negative 1. And finally, what's the value when x equals to 2? Well, that's going to give you a value of 0, which is this guy right there. All right, let's move on to the next question now. All right, so for question number 3, we're given 2 functions this time. I have another parabola there, and if I rewrite that parabola, I can rewrite that as y equals to negative x squared plus 1. If I rewrite it like that, then my vertex is going to be 0, 1, and this thing opens down. All right, so let's graph a parabola at 0, 1 with a vertex of 0, 1, and here's 0, 1 right here, and I want to have x values that are less than or equal to 0. So I go over to the left 1, down 1, and then from the vertex I go over 2 spots and down 4. So 1, 2, 3, 4. So there's a dot right there, and then I can just connect the dots here, and there's my parabola. That's y equals to negative x squared plus 1. Okay. Let me erase that. The parabola's done. All right, now I have this function over here. Let me write that as y equals to 1 over x, a rational function. So if you remember the parent graph from pre-calc 11, it kind of looks like that. And we want to capture this part of the graph here in yellow because we want the x values when x is greater than 0. So if I went ahead and graphed that part of the graph, it goes to the point 1, 1, and then I just carefully sketch the rest of the graph like that, and there's my middle graph, and now I can answer the following limit questions. So for letter A, I want to find out what the limit is when we approach 0 from the left hand side. So if I approach 0 from the left hand side, I follow this red line here, I'm getting close to x equals 0 from the left hand side, and the height that I get to there is going to be 1. If I approach 0 from the right hand side, well, I follow this graph here. So follow the red line. As I approach x equals to 0 from the right hand side, the height that I get to is positive infinity. And then I want to know the overall limit when x approaches 0. And since the left hand side and the left hand limit and right hand limit are not equal, this limit is going to be does not exist. And then finally, I want to find the y value when x equals to 0. So that's going to have a value of 1. All right, let's move on to question 4 now. All right, so some more functions that we need to graph. Then once we graph the function, I think finding the limit is actually not too bad. Okay, let's take a look at this rational function here. So if this is my rational function, I'll rewrite it as x squared minus 1 over x plus 1 on the side. We can factor this, so the numerator will be x plus 1, x minus 1. The denominator will be x plus 1. And you'll notice that these two binomials cancel off, and then your remaining function is x minus 1. So this is now a linear line with a hole. There's a hole at x equals to -1 because of the cancellation effect there. But I have a y-intercept of -1 and a slope of 1. So let's go ahead and graph that. So here is my y-intercept of -1. And my slope is going to be 1, so I can just draw a straight line here with the slope of 1. And when x equals to -1, I have a hole there. Okay, and so if I connected the dots here, this is what the graph will look like for my very first equation here. Okay, so factor that, cancel off the x plus 1 terms, and then you have a linear line with a hole when x equals to -1. This part right here also verifies that you have a hole, right? X can't be -1, so that's why we have a hole right there. Okay, let's move on to the next part, and the next part is just 3. So a y value of 3 when x equals to -1. So when I'm at -1, I need to have a height of 3, so let's put a dot right there. So there's my y value of 3 when x equals to -1. Alright, so that's how you graph that function. Now let's go ahead and answer the limit questions. So what's the limit when x approaches -1 from the left hand side? So if I'm approaching -1 from the left hand side, I can definitely follow this blue line, and this blue line, as it approaches -1 from the left hand side, the height that I approach is going to be -2. And if I approach -1 from the right hand side, which is this part in blue, that's also going to be a height of -2. And since the left hand limit and the right hand limit are equal, this will be -2. And then finally, I want to find out what the y value is when x equals to -1, and that has a value of 3. Okay, let's move on to the next one. Okay, so question number 5. I have 3 parts again. The first part right here might be a bit difficult to graph because I don't have the vertex, but we just have to do a little bit of work and just think about it. You can definitely factor out the x if you like, and that will give me x plus 2. And if I look at that, I have zeros at x equals to 0 for this guy right there, and at x equals to -2 because of that guy right there. So if I have zeros at x equals to 0 and -2, and this parabola will open up, then my vertex will be right there. All right, so mathematically you can use a little bit of symmetry there and find that the vertex is that point right there. Okay, so this is valid when x is less than or equal to -1, so I don't need this guy here. And if I go 1 over, I go 1 up. If I go over 2 spots, then I go up 4. 1, 2, 3, 4. So I need another dot there. I'm going to erase all those guys, and now I can connect the dots. So there's my parabola. All right, so that takes care of the very first part of the graph, the first graph there. And now we can move on to the middle graph, which is y equals to x when it's between -1 and 1. So straight line there. And I will put an open circle there. And then finally I have this guy right here in green, which is y equals to, if I rewrite it as -x plus 1, then there's a y-intercept of 1 here. And I have a negative slope, so it's going down like this. and this is valid when x is greater or equal to 1. So I'm just looking at this part of the graph right there. I can erase this I can erase the y-intercept over there, and that's what my graph will look like. So now we can go ahead and answer the limit questions here. Okay, so I'll use my black marker here. What's happening to this limit when I approach -1 from the left-hand side? So if I'm approaching when I'm approaching x equals to -1 from the left-hand side, the height that I get to is -1. And if I'm approaching -1 from the right-hand side, then if I'm approaching it from the right-hand side, this height is also going to be -1. Since the left-hand limit and the right-hand limit are equal, then this limit here has to have a value of -1. Okay, so let me just erase those guys. Now I'm approaching 1 from the left-hand side, so +1 from the right-hand side. So if I approach from the right-hand side, the height that I get to is this guy right here, which is going to be 1. And if I approach 1 from the right-hand side, then I look at this green graph. Whoops. Follow this green graph, and the height that I get to there now is going to be 0, and since the left-hand limit and the right-hand limit are not equal, this is going to be does not exist. Alright, let's move on to another graphing question. I think this is the last graphing question, so just one more to go. Okay, so for question number 6, I have a rational function to begin with. So if I rewrite that rational function here on the side, this is what I have. What you want to do here is you want to factor the denominator. If I factor the denominator, I get x minus 2 and x minus 1. Then these guys will cancel off, and now you're left with y equals to 1 over x minus 2. Because these terms cancel off, that means you have a hole at x equals to 1. Okay, there's a hole there. Okay, so when x equals to 1, let's go ahead and put a hole there, and the hole will be right about there. And I know that because when I look at this graph right here, I have a vertical asymptote at x equals to 2, so there's a vertical asymptote right here. And I know the graph looks like this. So it's a basic rational function there. Okay, and then we also have another point there, and the graph also goes like that as well. So there's my rational function there. Okay, and then I also have to graph this point here. So when x equals to 1, I have a, sorry, when x equals to 1, there's a y value 1, so that means that you have a dot right there. Okay, so there's my graph. Let me just get rid of all these, and let's go ahead and answer the limit questions. Okay, so when x approaches 1 from the left-hand side, so that's going to have a height of -1. Okay, so just approach it from the left-hand side. And if I approach 1 from the, oops, sorry, that's the wrong one there. Okay, so now I'm approaching 1 from the right-hand side. So here's 1, I approach it from the right-hand side, and the height that I get there is also going to be -1. And since the left-hand and right-hand limits are equal, this will have a value of -1 for the overall limit. Alright, so what about letter D? When x equals to 1, what is the height? Well, the height here is going to be +1. Let me just erase all that. And for the last two limits, I want to find out what the limit is when I approach 2 from the left-hand side. So if I approach 2 from the left-hand side, I need to follow this part of the graph and go straight down. So when I approach x equals to 2 from the left-hand side, I reach a height of -infinity. And if I approach 2 from the right-hand side, so when I'm approaching x equals to 2 from the right-hand side, I get to +infinity. Alright, so that concludes this video when we're actually graphing piecewise functions and answering follow-up limit questions.